Okay. First, I'm going to start by explaining what the sine function is. For each of these examples, we're going to start at the origin of 0, 0, this dot right here. As you can see with the sine function, it's always going to be a repeating pattern going between 0 to 1 to 0 to negative 1 to 0. Each of the values on the x-axis are labeled as one of the angles on a unit circle. You can see it goes over here on the line, on the x-axis, goes to pi over 2, pi, 3 pi over 2, and 2 pi. Similarly, you also have that on the unit circle. 0, pi over 2, pi, 3 pi over 2, and 2 pi. What the unit circle, what graphing the sine function is basically, it's demonstrating the pattern that exists when you move through each of these angles. Remember that there's these 4 points on each of the perfect angles. So, starting with, since we're going to be working on a sine function first, we have to focus on the y-axis because cosine, sine is the y value of a coordinate pair. So at 0, your y value is 0. That's why for the y value, you start at 0 here. Next, when you move over to pi over 2, your y value is 1, which is why the graph reflects that and it goes up to 1. For pi, your y value is 0, goes back down to 0. For 3 pi over 2, it goes down to negative 1, and the graph reflects this at negative 1. And finally, to complete a rotation at 2 pi, it goes back to 0, you go back to 0. Now, what one section of a function is called, as I marked with this orange thing right here, it's called a period. For any sine, cosine, or tangents, a period is a repetition in the graph that will always be reflected over and over again. So like you can see here, if you move it over, this part right here is similar to this part right here. So the periods will always repeat in between graphs. Moving on, this is the cosine function. Similar to the sine function, you're going to try to start. You're going to start at 0 on the unit circle. Since cosine will always be your x value, you're going to start with the x value of 0, 1. So on your graph, when x is 0, you're going to have your y value at 1 right here. Next, we're going to move over to pi over 2. You'll see your x value is 0, reflected in the graph going down from 1 to 0. You move to pi, your x value is negative 1. So you move down to negative 1. 3 pi over 2 is 0 again. Move back up to 0. And then 2 pi is 1. Move back to 1. Similar to the sine function, this part from 0 to 2 pi is called the period. And when you move over to see the other thing, I drew it poorly, but the period should repeat with the same dots. This is an easier way to graph functions, so that way you don't have to constantly go around the unit circle, because it works the other way around too. If you go to negative pi over 2, you go backwards, it'll still give you the same answer. It's just more tedious this way, which is why periods exist, to make it a little bit more simple to repeat the function. Now, for tangents, there's not really a way to explain it that I know other than just demonstrating. You're going to start at the origin at 0, 0, and then you're going to move over halfway between 0, 0 and pi over 2. You can see it at each other value, so at pi over 2, 3 pi over 2, negative pi over 2, 3 pi over 2, there's going to be an asymptote right here where the line cannot intersect, yet continues on in between these asymptotes forever and ever. For these points right here, your points are going to be at pi over 4, 1, and negative pi over 4, 1, directly in between the values at your asymptotes. Then you can just guesstimate where your line's going to be and just sketch it out. Similar to sine and cosine, you're going to have one period where this figure will continue to constantly repeat itself over and over again. When working with tangent functions, it's always best to map out your middle one right here at the origin to make it the easiest, and then note out each of your asymptotes to make sure you're doing it perfectly, like I noted here. So those are your three main functions for sine, cosine, and tangent.